And we're live. Hey guys, this is MediaNutso, and welcome to tonight's episode of MediaNutso Plays. Now, for those of you just tuning in last week we began our journey with the Freddy Fish series, where we helped solve the killer case of the missing cup seeds and the killer case of the haunted schoolhouse. Tonight we're going back to the realm of the Pokemon Learning League, in which we'll be cracking open a new chapter of this saga. After finishing off science, we're now delving into math lessons. Now, not to worry, this is not gonna be too tedious or boring. Now, if you've seen my post in the community tab, you'll know there's a few changes going on. There will now be a few changes made with the Learning League Livestream. Where beforehand, I used to they took 10 lessons per stream. And after thinking it over, I've come to the conclusion that was proving to be pretty tedious. So what I've decided to do instead, what I've done is structure the stream into 3 rounds, with each one consisting of 3 lessons. And as you can see, for our first round, we'll be delving into types of angles, the order of operations, and fractions. And one more thing, I'll be reading the plot synopses off of Bulbapedia. Though not verbatim, because it doesn't sound natural when I try to simp. But enough of my ramblings. Let's get things started with the first lesson on types of angles, in which we find Ash and Brock camping down and needing to pitch up their tent, but are having trouble following the directions as they're being presented in various angles. That sounds very thrilling. Here we go.
Alright, this new tent looks sweet.
Yeah, I can't wait to camp out in it tonight.
Pikachu!
Here, you read the instructions. I'll get the parts out of the box.
Deal. Okay, so the first step says put the center red pole at a 90 angle.
90 angle? Are you sure that's what it says? It sounds kind of weird.
At a 90 angle. Wait. Maybe it says 900.
Hold on. looks like some I forgot I had the redraw regions on. Let's start that back up. Let's back that up.
Alright, this new tent looks sweet.
Yeah, I can't wait to camp out in it tonight.
Pikachu!
Here, you read the instructions. I'll get the parts out of the box.
Deal. Okay, so the first step says put the center red pole at a 90 angle.
90 angle? Are you sure that's what it says? It sounds kind of weird.
At a 90 angle. Wait. Maybe it says 900. But that...
Okay, I've said this once before, but I understand that what the team was going for the characters learning along with the audience, as that has worked before in other educational games. But here they needed to dumb down the characters' intelligence in order for this plot to work. Which is pretty ridiculous considering who's being featured in it.
Arrow is smaller. Maybe it's just an ink blot?
Let me see that. Oh, you're right. A 90-degree angle.
Okay, cool. What does that mean?
B.
I'm not exactly sure. What's step number 2?
Attach the first blue pole at a 45-degree angle to the red pole.
And then what else?
Attach the other 3 poles at a 45, or it could be 450 angle.
You gotta be kidding!
That's all it says!
Oh, brother. How are we gonna put this tent up?
I think we're gonna need some help with this. Let's use the Pokepilot to ask Ada. She knows her way around numbers.
Good idea.
Hi, Ada.
Hey guys, what's up?
We're camping and are trying to set up a tent.
Sounds fun.
Yeah, but we're having some trouble with the instructions. It's like angle this and angle that with all these measurements. I mean, I know what angles are, but I'm not sure what to do with these specific degrees.
Yeah, how can you tell what the number means?
Gotcha. Sounds like we can tackle this problem by defining different types of angles. Let me tell you, once you start looking for angles, you'll see them everywhere. Like in a room. They're in corners, at the ceiling, and on the roof. You'll definitely need some angles if you're going to pitch a tent.
Yeah, that must be what's all over the place on these instructions.
You're right. Angles are measured in degrees. That's what that little O symbol after the number means. Here, let me show you what I'm talking about. We group angles by type according to their different measures. First, we have this one. The open door is making an angle. It's called an acute angle, and it measures between 0 and 90 degrees. Now look at this corner. It's a right angle. A right angle measures 90 degrees. Did you know right angles are the most common angles?
Oh yeah, like the corners of a box.
Or the seat and back of a chair.
Exactly. Now, let's shed some more light on this subject. Let's look at this window. When it's open, it forms an obtuse angle, which measures between 90 and 180 degrees. If you open the window as far as it will go, it forms a straight angle. Straight angles are straight lines and measure 180 degrees.
All right, I think I've got what you're saying. Acute, right, obtuse, and straight all refer to angles of different measures.
Right.
I just need to remember which is which.
That's the trick. Practicing with angles helps a lot.
But wait, what's that half circle thing you're using?
It's called a protractor, and it is used to measure an angle. Like, look at this angle. What is its measure?
Well, it's pointing to 60 degrees.
Right, it's 60 degrees. So what kind of angle is it?
60 is between 0 and 90 degrees, so it's an acute angle?
You got it. And you can always get the angle. Just place a protractor over the angle to find the measure.
Awesome.
A right angle measures 90 degrees, so it would look like this.
Sure, that makes sense. The angle measures exactly at the 90-degree point.
So what would an obtuse angle look like?
You're asking me?
Yep.
Well, okay. An obtuse angle would start out just like the other two angles, but it would measure between 90 and 180 degrees.
Yeah, like this.
Pika!
Now you can see how the protractor helps. You can use it to measure angles and to draw angles. To use a protractor, place the arrow on the corner, the vertex, of the angle you want to measure, and read off the measurement on the scale.
Okay, that's very helpful.
In degrees. This angle measures...
100 degrees!
Right. Now to draw with a protractor. First, you draw the bottom line of the angle and place the arrow in the protractor where the vertex of the angle will be.
Okay.
Then find the degree for your angle on the scale. Let's use 60 degrees.
That works.
Make a mark at 60 degrees. Then draw a straight line between the vertex and that mark.
That makes it simple.
Hey, that's pretty cool.
You got it. You just have to make sure you get
not
the
that
right
cool,
measure for
actually.
each type of angle. Acute, between 0 and 90 degrees. Right, at 90 degrees. Obtuse, between 90 and 180 degrees. And straight...
Is 180 degrees.
Right. So why don't you check out some of the angles you see around you in the woods for practice? Like that big tree with all those branches. There's got to be at least 100 angles on that tree alone.
Cool, let's practice.
Pikachu!
All right, I'm going to measure the angles of these branches, but I'm going to need some help. Are you in too? Great!
Okay, that was a very Dora the Explorer moment there.
Let's check these angles out. Okay, look at this first branch. I think the first angle is an acute angle. What is the measure on an acute angle?
Easy.
Right. An acute angle measures between 0 and 90 degrees.
Now, how would we draw an acute angle?
Anywhere between 0 and 90, so pretty much.
Right. An acute angle measures between 0 and 90 degrees.
Excuse background noise there.
Let's look at another branch. I think this one may be a right angle. What is the measure for a right angle?
Yeah, that's a very funky looking tree branch there.
Right. A right angle measures 90 degrees.
Hey, could you draw a right angle?
Right. A right angle measures 90 degrees.
Okay, look at this branch. I think it might be obtuse, but what is the measure for an obtuse angle?
It got a lot better going in order here.
Right. An obtuse angle measures between 90 and 180 degrees.
Can you draw an obtuse angle for me?
Right. An obtuse angle measures between 90 and 180 degrees.
This branch goes straight across to the other branch. They're at the same level. How cool! What is the measure for a straight angle?
To reiterate, it's really not that cool.
Right. A straight angle measures 180 degrees.
Can you draw me a straight angle?
Right. A straight angle measures 180 degrees. That's a straight line.
Hey, thanks for helping me practice.
Phew, Pikachu.
It's starting to get
Very
dark,
odd angle of Ash
and I
there.
think we're ready to set up the tent now.
Yeah, let's do it. Let's check these angles out. Okay, look at this first branch. I think the first angle is an... Hey, thanks for helping me practice.
Okay.
Well, here...
Alright, that last bit was pretty weird.
Well, here's a drawing of what it's supposed to look like. Help me find the angles in it. For each correct angle you find, I'll get to put together another part of the tent. Find a straight angle. You got it. Find an acute angle. All right. Find an obtuse angle. Awesome. Find a right angle. You got it. Find another obtuse angle. All right. Find another right angle. Way to go. Find another straight angle.
Again, I know this was meant for elementary school.
You got it. Find another acute angle. All right. Find another right angle. Awesome. Yeah, we did it. The tent is up and ready to go. To sleep in. Hey, Ash, Pikachu.
Since we learned about angles, everywhere I look, I see angles.
Huh? Yeah, I guess you're right.
Like Pikachu. Look at your tail.
Pika?
Let me get a closer look.
Well, it looks like you're pretty much in a straight angle now, Ash.
Corny to end a rather basic lesson. And now, on to the second in which we'll do all about order of operations, where Team Rock'em has stolen a chest of Pokeballs from Professor Oak's lab. But as they escape in true Team Rocket fashion, they accidentally close the and see that it's locked by a special lock with that has the combination hidden within very, very complex math problems. Then later, the chest is found by Ash and May, who must solve the puzzle using the order of operations. Already, right off the bat, this sounds like a more interesting lesson than types of angles.
Stealing the stash of Pokeballs from Professor Oak's lab was a brilliant idea.
Thank you. I can't wait to give all those Pokeballs to the boss. Giovanni will love us so much.
We'll have a delicious feast to begin.
And get a big promotion at the end.
Is that Professor Oak?
Let me see those. Oh, that's an oak tree, not Professor Oak. The coast is clear. Let's go.
That was a
Will
ridiculous
you
joke.
speed it up? It's so heavy. Are you helping at all?
Well, I would if I could see where I'm going.
Close the lid.
Well, I did close it.
I didn't say drop it. There'd better not be any damage to our loot. Open it and check.
I don't know why it won't open.
It was just open. Can't you do anything right?
Let me at it.
Yeah. Well, maybe it was a bad idea to close the lid in the first place.
I think it's locked. There's some sort of combination.
That's just a bunch of number mumbo-jumbo. What sort of newfangled luck is this? There must be a key to open it.
What key?
I don't know. Maybe it dropped. It's gotta be around here somewhere. Let's spread out and start looking.
But what if we can't find the little bitty key?
We have to find a way to open the lock any way we can. Now, fewer questions, more looking.
I can't believe all the Pokeballs are gone from Professor Oak's lab.
Why would somebody do this to Professor Oak?
Pika.
What do you think?
Well, whoever that somebody is, they can't be up to anything good. Come on, let's see if we can find the missing Pokeballs and help Professor Oak. Look, Professor Oak's chest. That's where he kept the Pokeballs. They should be in there. We have to check it out. Let's open it.
But it's got a puzzle on it, with numbers.
Maybe if we solve the puzzle, the lock will open?
Maybe, but how? All those numbers and symbols, what do they mean?
Let's call Ada for some help.
Ash, May, what's up?
We need your help. We've got to solve this number puzzle fast.
It has plus and minus signs all over it, and we're not sure where to start.
No worries. If you have math problems like the ones in your puzzle, where there are plus signs and minus signs and division and multiplication signs and so on, there's a rule that tells you what to do first.
Great! Maybe that will help us open the lock. Okay, what's the rule?
It's called PEMDAS. These are the first letters of the steps you follow when you solve this kind of math problem. P stands for parentheses. E stands for exponents. M for multiplication. D for division. A for addition. And S for subtraction.
Those are a lot of steps to remember.
You're right. But some people remember PEMDAS by saying, "Please excuse my dear Aunt Sally." Don't worry, you'll get
Oh boy, remember that acronym?
the hang of it. I'll talk you through the first problem in your puzzle. First, do you see parentheses?
Yeah, the 6 and 4 are inside parentheses.
Exactly. 6 times 4. You solve that part of the problem first. 6 times 4 is 24. Now, do you see exponents in the problem? It's a number that is on the right of a number, but raised a little above it.
Yeah, by the 5 there's a 2.
Perfect. That's 5 squared. The 2 is an exponent, so you solve that part of the problem next. 5 squared equals 25. Now, do you see multiplication or division signs?
Yeah, a division sign.
Right. 25 divided by 5.
And I see a multiplication sign.
You got it. 5 times 2.
But which one do we do first?
If you have a multiplication sign or a division sign, you do them in order from left to right, like when you read. So, since 25 divided by 5 is the furthest to the left, you work that out first. 25 divided by 5 equals 5. Then you multiply. 5 times 2 equals 10. And now, do you see addition or subtraction signs?
There are addition and subtraction signs. So we'd go from left to right again?
Yes. 24 minus 10 is the furthest to the left side, so we work that out first. 24 minus 10 equals 14.
And finally, 14 plus 10 equals 24.
Right. So 24 is your answer.
All right.
If we follow the order of operations, PEMDAS, we'll be able to solve the puzzle and open the lock.
Very good.
Right. But keep in mind, if you don't follow PEMDAS, your answer could turn out wrong.
Got it. We gotta do this quick since the thief might be nearby.
Thanks, Ada.
Or thieves in this
Anytime.
case.
Let's hurry and open the chest.
Stealing this.
Take a look at the puzzle.
Highlight and click on the part of the math problem you should solve first. Yeah, 4 times 2 are in parentheses, so we work that part out first.
Yep.
And that leaves 3 squared. We'd work that out last.
Let's do the second one.
Well, you're right that multiplication or division come next. But
Yeah!
Right. Go left to
16
right.
divided
Not
by
left,
4
right.
goes first. Because it's a multiplication or division sign, and it's furthest to the left.
now highlight and click on the part of the problem to solve next.
Yes! Multiplication, and that comes before addition and subtraction. We're getting there.
Highlight and click on the part of the problem you should solve last.
It's the only one left.
Yeah! We add 2 plus 3 last.
One more problem to go. Let's try this one.
Highlight and click on the part of the problem to solve first.
Yes, we add 3 plus 4 first because they're in parentheses.
Which part?
Yes! 2 squared. Because exponents come after parentheses in the order of operations.
Let's keep going.
Highlight and click on the part to solve last in this math problem. Well, you already decided 3 plus 4 goes first because they're in parentheses. And then comes 2 squared because it's an exponent. So what's left?
Yes, 9 minus 6 is subtraction,
Again,
and that's
yep.
last.
In the home.
Yay!
Left to right.
Awesome. We're ready to crack this puzzle and take back the stolen Pokeballs to Professor Oak.
I've got an idea. You work out the 3 math problems, now that we know how to solve them. And we'll stay on the lookout for the thief. Then we can bring the Pokeballs back to the lab as soon as we open the chest.
Take a look at the puzzle.
Highlight and click on the part of the math problem you should solve first.
Here's the puzzle.
Well, at least this one actually pauses right.
Here's the puzzle.
Start with the first math problem. You might need scrap paper and a pencil to solve it.
Let's see.
After you solve each problem, click on the key that matches your answer. Great work! Click on the key that matches your answer. Yeah!
Yeah, got it.
Click on the key that matches your answer.
Yeah, got it.
Yeah!
Awesome
And I
job!
didn't need any scrap paper.
Yes! Let's take the Pokeballs back to Professor Oak, but leave the box here to fool the thief.
That's it. I'm sick of searching. We'll get that lock open, even if it takes a blowtorch. Huh? I guess it just needed some of Meowth's magic claws.
No, it didn't.
Pokeballs! They're gone!
Team Rocket! We should have known it was you! But
No duh. Even at this point in the series, you really should have known it was them from the very beginning.
how did you get the lock open? It was foolproof!
Let's just say we had a little help from PEMDAS.
Who's that? Another twipe?
Maybe this PEMDAS person has some Pokemon we can steal and add to our collection.
Yes, nothing for us here.
But even they can't figure out what PEMDAS is. You know there's something wrong with them.
PEMDAS, you now have Team Rocket to fear!
Okay, like I said, this was definitely more interesting than types of angles. Now to move on to the third lesson of this round, fractions. Hold on a second, let me get the synopsis. Here we go. In Fraction, we find Ash and May traveling through a forest where they decide to take a little stat break, only to find out that they have one Watmobile berry left. So they decide to split it so that both they and their Pokemon get an equal share of it. Yeah, this will be by far the simplest lesson of them all. Oh, and also notably one of the early ones too. Before I continue, there's one little neat tidbit I found out while setting up. If you hit 100%, just watch. Look at that. Just zooms out. But that's not even the best part.
Hey, May, it looks like our Pokemon are getting hungry.
Look at that.
Maybe we should take a break and give them a snack.
Oh,
Oh,
just our Pokemon, huh?
Hey there!
Glad you could join us.
Okay, enough about them. Now let me set the screen back to normal.
Hey, May, it looks like our Pokemon are getting hungry. Maybe we should take a break and give them a snack.
Okay, as you could probably guess, that's KZ Rogers voicing Ash. Well, I already went over this during the science topics, so I won't repeat myself here. But basically, when the voice cast change happened, and they were originally going to have KZ Rogers take over as but because that didn't go over too well with the fans, they later on hired Serenado Chenny to do the voice. Obviously this and the Lunar Cycle were the earliest ones produced, and as a result, were the only ones to have much of KZ Rogers' original recordings preserved, thus giving us a glimpse at what the dub would have been like had they stuck with KZ Rogers voicing her all the way through.
Oh, just our Pokemon, huh?
Wow, they really forgot to add a stomach growl sound effect there.
Hey there!
Glad you could join us. We're
But-
just about
and
to
it's
give
also
our
by
Pokemon
far
a snack.
the most Dora the Explorer of them all.
How are 4 Pokemon gonna share one berry?
Good point. We have to make sure they each get an equal piece, or we'll have some very upset Pokemon.
And again, how they did not know how to split it evenly.
Let's see if we can get some help on this. Ada at the Learning League Lab is really good at solving problems. She'll be able to help us out.
And yeah, that is the one bit of dialogue done by Serenado Chenny.
Hi there, Ash. Hey, May, what's new?
Hi, Ada. We actually just stopped to give our Pokemon a snack, and we need to figure out how to split this berry so that each gets an equal part.
No problem. I'll help you through it.
Thanks, Ada.
Okay, so what we are talking about is a part of a whole. Let's look at your berry as our example. The berry is a whole. Now, if it is cut into 4 pieces, each piece is a part, or fraction, of the whole. Each piece is 1 out of 4, or 1/4. So, the number on the bottom of a fraction is the number of all the pieces that make up the whole. That number is called the denominator.
Okay, so we cut the berry into 4 pieces. So the denominator, or total number of pieces, is 4.
What's the number on top of the fraction?
That's the numerator. The numerator tells how large the fraction is.
I got it. Each Pokemon is getting 1 of 4 pieces of the berry. Each Pokemon is getting 1/4 of the berry.
You guys are doing great! Why don't you figure out some more problems with fractions?
Awesome!
Ready, guys?
Okay, first one. If we split the berry into 2 pieces, what fraction would we have?
Well, hold up there. What was all up with those recordings there? Those were a lot more muffled than normal. I'm good. Guessing something must have went on done with the recording equipment during around that time.
If you split something in 2, each piece is 1/2.
Let's try some more problems.
What if we wanted to share the berry with 5 Pokemon? What fraction of the berry would each Pokemon get?
If you split something in 5, each piece is 1/5.
What if we wanted to share the berry with 3 Pokemon? What fraction of the berry would...
If you split something in 3, each piece is 1/3.
What if we wanted to share the berry with 4 Pokemon?
AKA
What fraction of the berry would each Pokemon
the very
get?
fraction we started with.
If you split something in 4, each piece is 1/4. Good job, guys. I'm sure your Pokemon have worked up an appetite.
No fractions here. I want 1 whole of this sandwich.
You guys are doing great. Why don't you figure out some more problems with... You guys are doing great. Why don't you... If you split something in 2, each piece is 1/2.
Let's try some more problems.
What if we wanted to share the berry with 5?
If you split something in 5, each piece is 1/5.
What if we wanted to share the berry with 3?
If you split something in 3, each piece is 1/3.
What if we wanted to share the berry with 4 Pokemon?
If you split something in 4, each piece is 1/4. Good job, guys. I'm sure your Pokemon have worked up an appetite.
No fractions here.
As
I
I was about
want
to
1
say,
whole of
I
this
can
sandwich.
imagine a long lot of advanced shippers getting a lot of mileage out of this lesson.
Come on, Max. Well, thanks for your help anyway. You're great at fractions.
Are you ready?
Good job.
See you. Are you ready for a challenge on your own?
See if you can match the fraction and the number. If you can, there's a hidden picture underneath.
Me doing it. For some reason, that's how the file is playing.
Good job.
Are you ready for a challenge on your own?
See if you can match the fraction and the number. If you can, there's a hidden picture underneath.
Because of course they would do one of these kinds of puzzles.
Good job. See you next time.
And like I said, and by far the simplest lesson of the whole learning league. Well, anyways, we're gonna go on to our first break, so I can set up the Oh, sorry, I forgot. Well, that'll do it for the first round. Now we're gonna take a short break, so I can set up the next round. Right, and with that's it said, I'll be right.
Okay, let's bake. Well,
You might need to.
I need to find.
Oh, yeah!
Now you're getting it.
Hey, and we're back. Now it's time to get on with round 2, in which we'll tackle discounts, area of a circle, and add and subtract fractions. As you can clearly tell, this stream will have 3 different lessons involving fractions. But enough about them. Let's get on with discounts, in which we'll see that where we find Ash watching Brawley surf for Big Woman, but then wipes out and gets his surfboard broken. So Ash decides to do a nice thing and buy him a new one. Only one problem: he's not sure which shop has the least expensive board. Thus, he contacts Ada for some help.
Whoa, what a wipeout! I hope Brawley's okay.
Pika.
Man, that was some wave. I got crushed.
Yeah, interesting foot bump. That's Bill Rogers voicing Brawley. He only voices the character for just 2 lessons in the learning loop. And never in the actual series.
At least you're okay. That's what's most important.
Yeah, but my board's totaled. Major bummer. I'm landlocked, dude.
We gotta do something. Hey, look at that! The Wave Rider Extreme! Maybe we can all pitch in and get Brawley a new board as a present. But I saw the same one at a different shop yesterday. Maybe I should go there instead? I think a surfboard is pretty expensive. Let's call Ada. She'll help us figure it out. Hi, Ada.
Hey, Ash. What's up?
Well, I'm checking out surfboards for my friend Brawley at different shops. Surfboards can be expensive, so I'm trying to figure out which one is cheapest.
Shopping? No problem. I'm an expert. So let's talk about what you would do to compare how much the boards cost, their price, at the different shops. To start, what if I told you I saw 3 different prices, $200, $180, and $150? Which would be cheapest?
That depends. Are you talking about dollars or poke yen?
Right! But that price isn't always the final price. Sometimes you see a sign that says some % off. For example, 20% off. And that means a sale. A sale can mean big savings or just a few dollars off. To figure it out, you need to check the regular price and the % off or discount. They both affect the final sale price.
So, how do I figure out the rest?
No sweat. In fact, once I got it down, I was using percents to figure out discounts all the time. Like yesterday, I got this great pair of shoes on sale, and then, when I was walking back to the lab, I saw another sale with this awesome bag. And of course, I had to get it because it went with the shoes and,
Got a little carried away there. But in honesty, I could say, a lot of bargain shoppers can relate to that.
Ada?
oh, sorry. It's just such a great thing to know, and I just love a good sale. So here we go. Let's say a surfboard regularly costs $200, and on sale, it's 25% off. To calculate the reduced sale price, we first have to find 25% of $200, and then subtract that amount from the regular price. I call that descent by the percent.
Okay, so step 1. 25% of 200?
Can you give it a try? How do you find the percentage of a number?
Oh, you multiply the number by the given percent.
Right.
Wow.
25% of 200 is the same as 200 times 25%.
But how can I multiply a percent?
Percents can be written in different ways. I usually change the percent to a decimal. To change a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Now, get ready for some multiplication calculation. Okay, in goes the regular price and our decimal percentage, 0.25. Now, let's calculate. Don't forget, the number of decimal places in the product equals the total number of decimal places in the factors.
Got it! So the decimal point goes 2 places to the left. Cool! 25% of 200 is 50. But we still don't know the sale price.
It's time for step 2. We have to subtract the percentage amount from the regular price to get the sale price. Remember, descent by the percent. In goes the regular price and the percentage amount that we have to subtract. Get the numbers straight, then calculate. So the price of a surfboard that regularly costs $200 but was on sale for 25% off would be
$150.
Yeah, very good.
Now you're getting it. How about trying out a practice problem? I'll give you another example. This time, we'll make the regular price $190 and the sale 30% off. So, what's the sale?
What's the first thing we have to do?
Click on the step to take. If you need help, click the Sale Steps button.
According to step 1, we have to start by finding 30% of 190. So we have to multiply.
Click Multiply. Now, drag numbers into the boxes to fill in the regular price and the decimal representation of the percent. When you're finished, click Calculate. Good job!
Yeah! 30% of 190 is 57. Now for step 2.
Click Subtract.
Okay, here we go. Fill in the regular price and the percentage amount to subtract.
When you're finished, click Calculate. There you go!
Awesome! The sale price is 133.
100% correct! You're ready to go, so shop till you drop.
Oh yeah, I'm ready now.
Hey, Ash, you busy?
Brawly, I was just thinking of you. What's up?
No action here, dude. None. Nada. Zip. Boy, I sure miss my board.
Don't worry, Brawly. I have a feeling your luck's about to change.
Sure hope so, pal. I'll catch you later.
Now you're getting it.
Oh, oh yeah! Brawly's gonna be so pumped when he sees his new board. Are you ready to do some board shopping? Pikachu! Here you go. Check out this info. It's from the first store.
Fill in the correct numbers, then calculate the multiplication.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, then calculate the subtraction.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. Okay, on...
Fill in the correct numbers, then calculate the multiplication.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, then calculate the subtraction.
Yeah, again, anyone always looking for a good discount, let's say Walmart or a grocery store, we'll get a lot of mileage out of this.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. One store to go. Here's the sale.
Fill in the correct numbers, then calculate the multiplication.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, then calculate the subtraction.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. All right! You figured out the information we need. Now let's compare the sale prices for the 3 stores. Click on the store with the best price for the Wave Rider Extreme.
That's easy.
Excellent! Hang 10 definitely has the best deal. Come on, let's go. Wow! This board's great. Brawly's gonna be so surprised.
Absolutely.
Oh,
Again.
man, I can't believe it. A Wave Rider Extreme? Totally awesome, dude.
Glad you like it, Brawly. There's nothing better than a happy surfer, dude. Thanks, pal, for helping me pull it off.
Again, another somewhat door-esque ending. But seriously, that was a pretty nice lesson. Now on to the second one. Well, it was all about finding the area of a circle. And for this storm, and this one's a Misty-centric storm. In this case, we find Misty. In this we find Misty Psyduck standing on the rim of a tank of water, and which of course it falls in and struggles to get out. After Misty helps it down, she decides to put a cover on the tanks all over the gym. Only one problem. She has to find the area for the top of the circular tanks. Oh, no, that was archive recordings of Michael Hagney's doing Psyduck.
Here you go, Psyduck.
Psyduck.
That's the third time you fell in this week. We're going to have to put a cover on this tank.
Psyduck.
Of course, you could just stop playing with the water, but I think covers may be better. I'll make sure you're safe.
Psyduck.
Now, I just have to get a measurement for the size of the cover. The cover needs to fit across the top of the tank. With the rectangular tanks you fell in, it was easy. I just multiplied the length of the tank by its width. That gave me the area of the top of the tank. That was the size we needed for the cover. But how do we find the area for a tank in the shape of a circle?
Psyduck.
We're going to need some help with this. Let's use the Pokepilot to contact Ada. Hi, Ada.
Hi, Misty. How are things?
Things are good. Well, maybe not for Psyduck. I have a problem, and I thought you might be able to help.
Sure. What's up?
We've been making covers for some of the Pokemon tanks. They keep Psyduck from falling in the tanks.
Psyduck.
Well, that sounds like a good idea. So what's the problem?
To make the covers, I need to know the area of the top of the tank. I know how to find the area for a rectangle, but we have a lot of circular tanks. How do I find the area for the tops of those tanks?
I can help you with that. So first, tell me about the tank.
I'll show you. It's a tank with a round top that is 2 meters across.
Okay, so if it's 2 meters across, we say its diameter is 2 meters.
Huh?
Psyduck.
Yep. The diameter of a circle is the length of a straight line from one point on the edge of the circle through the center of the circle to another point on the edge.
Okay, so the diameter of the top of this tank is 2 meters?
That's right. To find the area of the circle, though, we need to find the radius. Do you know what the radius of a circle is?
I think so. It's like a ray of light. It goes from the center to the outside?
That's a good way of thinking about it. It's the distance from the center of the circle to an outside point. It's also half of the diameter. So in this case, the diameter is 2 meters, meaning the radius is
1 meter.
Psy.
You got it. We can use this radius in the formula for finding the area of a circle, pi r squared.
Psyduck.
Sounds funny, doesn't it? R stands for the radius, your ray from the center. R squared means you multiply the radius by itself, or square it. And then pi is the ratio of the circumference of a circle to its diameter. Remember, the circumference of a circle is the measure all around the edge of the circle. And so pi is actually a number, 3.14. To find the area of the top of a circular tank, you would multiply pi by the radius squared.
Okay, for this tank, we would multiply pi by 1 squared, since the radius is 1 meter. 1 multiplied by 1 is 1. So the area of this circle is 1 pi.
That's it. Now all you have to do is multiply 1 by pi, or 3.14.
That is 3.14 square meters.
Great work!
Very
You'll need
good.
3.14 square meters of material for the top of this tank.
Great! I can make sure we get enough cover material for this tank. But we should probably cover another tank just to be sure.
Psy.
It's okay. Would you help me find the area of another circle for tank covers? Let's do it.
Very well then.
I need to find the area. I need to find the area for another tank. Will you help me?
What is the formula for the area of a circle?
Easy.
Right! The area of a circle is the radius squared times pi. What is the radius of a circle? Is it the distance around the outer edge of the circle? The distance from the center? Right! The radius of a circle extends from the center to the outer edge of the circle. The diameter of this tank is 20 decimeters. What is the radius? Right. The radius is half of the diameter, or 10 decimeters. What is the radius? 10 decimeters squared. Right. 10 multiplied by itself is 100. What is the area of a circle with a radius of 10 decimeters? Right. The radius squared is 100, and 100 pi is 314.
Yep.
You guys did great. Are you ready to try a bigger challenge? Let's go.
Yeah, many of these lessons always have to end with, want to do a bigger challenge? Which, thankfully, they had the characters stop saying.
You might need to use scratch paper or a calculator for this challenge.
Psyduck needs help getting across this path. There are holes on the trail. Don't let Psyduck fall in. To fill in the hole, drag the correct circle to a hole by finding the area, radius, or diameter of the hole. Wrong circles just won't stay in place. Help Psyduck! Fill these holes with more circles. Awesome! Here are more holes to fill. Excellent! Help Psyduck! Fill these holes with more circles. Awesome! Help Psyduck! Fill these holes with more circles.
Yeah.
Awesome! Which circle will fill the hole in the path? Awesome! Here are more holes to fill. Great! Here are more holes to fill. Excellent! Which circle will fill the hole in the path? Excellent! Help Psyduck! Psyduck! Fill these holes with more circles. Try again. Excellent. Help Psyduck. Fill these holes with more circles. Awesome.
Yeah, got it.
Now you can use the
and
area
yeah,
of the
and
circle
yes, I
formula
did
to
use a
find the right
calculator.
size
How
for the
did you
covers
guess?
and anything else you might need.
Thanks, Ada. Now we'll be able to keep Psyduck dry and safe.
Glad I could help. Bye.
See ya! Okay, Psyduck,
Very good
let's make
indeed.
some more covers.
Psyduck?
What do you know? Oh, it works.
You might need to use...
Well, I'll admit, that was another fun one. Now let us move on to our second fractions lesson of the Stream, which will deal with adding and subtracting for fractions. Oh, and it happens to be centered on Mum, who decides to surprise her for friends by making a cake while Brock is making dinner. Okay. There's only one thing. She only has 2 measuring cups to work with, and thus contacts Ada to find out how to add and subtract fractions. Excuse me there.
While Brock is busy making dinner, I'm going to surprise everyone and make dessert. Yeah. I know what you're thinking. Brock usually does the cooking.
And
maybe
reference to
my
her
past cooking attempts haven't turned out so,
her purple
tasty.
Pokeblock
But come on,
surprise.
how hard can it be? So, I'm gonna make a cake.
You tripped on my words
and they're
there.
gonna love it. I'm gonna make them love it. I just have to get out my measuring cups. Let's see. I've got 1/3 of a cup and a 1/4 of a cup. And it looks like that's it for the measuring thingamajigs.
Really? Thingamajigs? Couldn't say just cups?
Time to get started. It says here I need 3/4 of a cup of oil. Uh-oh. 3/4? I don't have a 3/4 measuring cup. What do I do? Maybe I should just dump the whole bottle in?
Whoa, bad idea, though. Also, really, you can't figure out just use the 1/4 cup 3 times.
No, that can't be right. I better
Then again, we wouldn't have a lesson otherwise.
call in some backup. Hi, Ada. What's up?
Hey, May. I've been in the lab all day and I'm starving. I was just about to have some pizza. How's it going?
Good. I'm trying to make a cake and need your help. I need to figure out these measurements. I need to come up with 3/4 of a cup of oil, but all I've got is a 1/4 cup and 1/3 cup for measuring.
No problem. So since you said you need 3/4 of a cup and you have a 1/4 measuring cup, I'll show you how to add fractions with my pizza.
All right. Adding is a piece of cake.
Well, in my case, pizza pie. See here? We have 1, 2, 3, 4, 5, 6 slices. Each slice stands for 1/6 of the pie.
With you so far. I've used fractions before.
That's great. Well, then you'll remember that when we look at the fraction 1/6, the number on the bottom of the fraction is the total number of parts.
Right. The denominator. Like with your pizza, the denominator is 6? Because
good
there
memory
are 6
there.
slices of pizza?
Exactly. And then the number on the top of the fraction is how many parts we're using out of the total number.
And that's the numerator.
Excellent. So, the numerator in the fraction 1/6 is...
The number 1?
You got it. So now to adding. If one piece of pizza is eaten, guess the students here are hungry too.
Yeah, maybe you shouldn't have left the pizza out, Ada.
Anyway, that's 1/6 of the pie. Okay, so if I eat 2 slices of pizza, that's 2/6 of the pie.
And three more
Wow,
slices
looks
gone.
like everyone around here wants pizza.
Okay, but what have the students ate in total so far? What if we want to add 1/6 and 2/6 together?
That's adding fractions. You'd write it like this. And then you'd add the numbers in the numerator together.
Oh, you mean when the numbers in the denominator are the same, you just add the numbers in the numerator together?
Yeah. So you go 1/6 plus 2/6 equals
3/6.
Right. And then you can also reduce 3/6 to 1/2. And here's proof. Half of the pizza has been eaten. Make that all the pizza has been eaten.
Awkward.
Which means 6/6 of the pizza is gone. Or one whole pizza is out of here. Because whenever the numerator and denominator are the same, they're equal to 1.
So, like 7/7 equals 1? And 9/9 equals 1?
You got it. And now I'm really, really hungry. So I'm going to eat this other pizza.
But wait! What about if we want to look at the pizza the opposite way? What was left instead of what was eaten?
Great question. Let's take a look. Here you see again, we have 6 slices of pizza. And...
Not again.
That was convenient. So we started with 6 slices. And now there are 5 slices missing. So 6/6 minus 5/6 equals 1/6.
So when you subtract fractions, if the denominator is the same, you just subtract the numerators?
Exactly.
So to get the 3/4 cup of oil I need, all I have to do is use the 1/4 cup 3 times.
May, that was seriously impressive. I think you're ready to make that cake.
Thanks. I think so too.
Good luck. And now,
Okay, that was just rude.
I'm going out to eat.
Good idea.
Okay, let's bake this cake. How many scoops with the 1/3 cup will it take to make 2/3 of a cup? Awesome! Now I need to add 1 and 2/3 cup of sugar. How many scoops with my 1/3 measuring cup will it take to make 1 and 2/3 cup? Yeah, that's right! Okay, now it says I need 3 and 1/4 cups of flour. How many scoops of my 1/4 cup will I need? Awesome!
Yep.
All right. All I have to do is mix and bake. Now it says I need to pour the cake into 3 pans that are the same shape and size. How should I evenly pour the batter?
Easy.
Awesome!
Yeah, at this point, it's obvious this was another one of the easier lessons.
Now it's baking time! All right! I iced it and it looks delicious. Now they'll have to take back what they've said about my cooking.
Hey, May, where have you been?
Toiling away in a hot kitchen. All for you guys. Aren't I sweet? I baked a cake for dessert.
You? Baked?
Yes, I baked.
Oh no, did we do something wrong? Since when do you know what an oven looks
Whoa,
like?
whoa, don't jump to
Come
conclusions
on.
there.
Really? It's good this time. I got some help. Just try it.
All right, we'll give it a try. Let's dig in.
That was one delicious dinner.
Thanks.
Yeah, I'm stuffed. And nay, that was actually a really good cake.
See? Told ya.
Must have been a once-in-a-lifetime thing.
Oh,
Just
it won't be.
kidding.
Well, we have enough leftovers here to last a lifetime.
Don't worry. We won't let any go to waste. I brought some containers. Let's figure out which container fits the cake best.
Hey.
What fraction of the cake can fit in this container? Awesome! How much cake is left out of the container? Yes! You got it! Drag and drop as many slices in as you can. What fraction of the cake can fit in this container? Awesome! How much of the cake is left out of the container? Yes! You got it! Drag and drop as many slices in as you can. What fraction of the cake can fit in this container? Awesome! How much of the cake is left out of the container? Cool! Click on the least number of containers you'll need. Yeah! Hey, amazing job! Thank you! We got all the food packed up to go.
But now what are we gonna do with it?
Who wants to take home the leftover cake?
So full.
I'm stuffed.
Looks like now we wish we ate a fraction of what we did.
Looks like you. Well, that'll do it for round 2. Now we're gonna go on to our next ring, so I can set up the nut. We're gonna set them up for the final round. Right, we'll be right back.
Now I need...
Okay, let's take a look.
Hey, look!
That was awesome. Let's do it.
You guys did.
We have to find...
There we go. No, and we are back. Back with our third and final round of the stream, in which we'll be tackling equivalent fractions, percents, and mean, median, range, and mode. Oh, and of course, we're kicking things off with our third fraction-based lesson in equivalent fractions, in which we find Ash and the gang deciding to take a break from their traveling. From there, Ash lets its core fish out so it can have something to eat too. But then it grabs onto Ash's backpack, and then many of the cans of Pokemon food fall off a cliff and into a river. Now the group is low on food. Now that the group is low on food, they decide to split it among each person so they all get a fair share. Only they can't figure out how to can't figure out how to split the grapes and a loaf of bread. Yeah, Kim. And this is gonna be another their early lesson. But enough about my ramblings.
Hey, Brock, let's stop for something to eat in a little while.
Okay, maybe in another half hour.
Cool. I've got the snacks in my pack. Maybe Corfish should have some Pokemon food. I have some Pokemon food for it in my pack along with ours.
Fish.
Yeah, we'll stop in a little while and give you some food.
Corfish.
Pika!
Corfish, what are you doing? Oh no!
Why you decided to do
What was that?
Those were our snacks. At least some of them. Corfish!
Corfish! I guess Corfish didn't want to wait for its snack.
And again, like I said, you get to tell this is another one of the early lessons.
Oh, brother.
Corfish's food may be down in the water, but let's see what we still have for us. We have 4 bottles of water, grapes, and bread.
Now that we don't have as much to eat, we have to make sure everyone gets a fair share.
Yeah, we all need the energy, especially with Corfish around. Let's divide the snacks evenly.
We each get 1 bottle of water because there are 4 of us. You, me, Max, and May. That's easy. But how many grapes do we each get? If there were just 4 grapes, we'd each get 1. But there are more than that.
Good questions.
Since there are 4 of us, all the snacks need to be separated into fourths. We each should get 1/4 of the snacks. How do we find what 1/4 of the grapes is? Or 1/4 of a loaf of bread?
I bet Ada would know. Let's call her. Hi, Ada. I'm here with Brock. May and Max are with us, too. Would you help us with some questions?
Hey, guys. Sure. No problem.
Hi, Ada. You're a vision of loveliness.
Rare block from for Ada.
A sight for sore eyes.
Thanks, Brock. What's up?
Some of our food fell over a cliff, and now we need to divide up what's left for each of us.
I know that since there are 4 of us, we each get 1/4 of the snacks. That way, May, Max, Ash, and I get the same amount. But how do we find 1/4 of a loaf of bread with more than 4 slices?
No problem. We'll just come up with different ways you can represent the same amount. It can help you get your snack sharing worked out in no time.
That's good. I'm getting hungry. That bread is looking good.
What? Ash, we'd better get started or there won't be any snacks to share.
Okay, then. What snacks do you have?
We have bread and a bunch of grapes.
Right. Let's start with the bread. Since there are 4 of you, we could simply divide the loaf into 4 parts.
Okay, who was talking then there? That kind of sounded like a prototype of Ada's voice.
This way, you'd each get an even amount. You'd each get 1/4 of the bread.
But Ada, what about all of the slices?
Good question. Let's take a closer look. How many slices do you see in each one of these 4 sections?
Let's see. There are 1, 2, 3, 4. 4 slices in each section.
Right. So each person would get 4 slices. How many slices are there in all?
16.
Exactly. Now here's the cool part. The 1/4 of the loaf is exactly the same as the 4/16 of the loaf. It's just 2 different ways to show it. Both show the amount each person gets of the loaf, one in sections and the other in slices. But they are exactly the same.
Wait a minute. So you're saying that 1/4 is the same as 4/16?
Exactly. They are called equivalent fractions.
So, you mean they're equal fractions?
Yes. Equivalent fractions are 2 or more fractions that have the same value but are written in different forms. You can find an equivalent fraction by multiplying the numerator and denominator by the same number, like this. If you multiply 1/4 by 4/4, which is the same as 1, you get 4/16. Or, if the numerator and denominator of a fraction are both divided by the same number, you can get an equivalent fraction that way too.
Okay, I get it. Both fractions represent the same amount, so they are equal fractions. You can show them in a picture or with numbers.
You've got it.
But Ada, how does it work with grapes? We're not going to break a grape into fourths.
I could just eat them all and we wouldn't have to worry about it.
Here we go again.
Brother.
Let's take a look at the grapes. How many grapes are there?
There are 24.
Okay. So each one of you is going to get some part of 24 grapes. We can show that like this. In fact, each of you is going to get 1/4 of 24 grapes. We can write that like this. 1/4 equals some amount of 24ths. Now we use what we know about equivalent fractions. You can multiply both the numerator and denominator by the same number to get an equivalent fraction. So what would we multiply 4 by to get 24?
6. So, I guess we multiply 1 by 6 to get the numerator in the second fraction.
6 times 1 is 6. So 1/4 times 6 equals 6/24. 1/4 and 6/24 are equivalent fractions.
Right.
Bingo.
Let's take it back to the grapes now. You have 24 grapes. Since 6/24 is equal to 1/4, if you each get 6/24 of the grapes, you'll each get 1/4. Now we have 4 groups of grapes. Each has 6 grapes in it. Will everyone get the same amount?
Yup. We each get 1/4 of the total grapes, which is 6 grapes.
Because 1/4 and 6/24 are equivalent fractions.
You got it. It sounds like you guys are getting close to enjoying that snack.
It would be more enjoyable if you were here.
Come on, Brock. It's time to eat.
Carfish! Okay. But wait. Like Ada said, we're getting close. But we've got more to do.
Okay. Would you help us? Let's do it.
We have to find more equivalent fractions to get these snacks divided right. If we had 4 grapes for 4 people, we would each get 1 grape. What if we had 16 grapes? The equivalent fraction would be 4/16. So if we had 16 grapes, we'd each get 4 grapes. If we had 4 grapes for 4 people, we would each get 1 grape. What if we had 8 grapes?
Click the number of grapes that each person would get showing an equivalent fraction. Then, click the check button. For help, click the hint button.
That will be the only time they acknowledge the hint button.
Nice work.
Awesome. Awesome. You did it!
We have to find more equivalent fractions to get these snacks.
You guys did great! Are you ready to try a bigger challenge?
Yeah,
Oh yeah,
let's do
another
it.
bigger challenge.
See if you can put these fraction snacks into the correct backpack. Using your mouse, aim each snack toward the backpack labeled with an equivalent fraction. Then click to toss the snack into the pack.
Ready? Aim and go!
Vika, Vika!
You did it!
Vika, Vika!
Way to go!
Vika, Vika!
Right.
Vika, Vika!
Way to go!
Very good.
So now you know all about equivalent fractions.
Great! That means it's time to eat.
I will be counting the minutes till we speak again.
Oh, give it a rest already.
All right. Talk to you later, guys.
Thanks for your help, Ada. See you later. So, if I understand this equivalent fraction thing, I get to eat all the snacks, right?
Vika, Vika!
Huh?
Just kidding. No sweat.
Hey, what's that floating down there? Ah, there's the Pokemon food. It fell into the water.
Hey, maybe
Where
we
else
can
would it
fish
have-
out
would it
their
have
snacks too. Let's go down to the beach.
Let's go.
Vika, Vika!
And of course, we don't get to see them do it. So yeah, that was another simpler lesson. Now to move on to our second to last lesson of the Stir Dream, in which we'll be tackling percents. And once again, it features Brawley, who just had a surfboard tryouts competition where Ash, May, and Max competed. And they all wish that they made the team as a lot of people tried out. Now, may wonder how Brawley will choose the best three surfers for his team. So they can get in touch with Ada, who suggests that the best way to look at it would be through percents. And already this is sounding more interesting than this.
Hey, great tryouts, dudes. You rode some killer waves this week.
Thanks, Brawley.
Boy, I hope I made the team. I sure had a hard time staying up on my board a few times this week.
Yeah, it was pretty tough, even though Max and I practiced all week.
Remember, the top 3 surfers get a place on the Board Blasters team. Check in tomorrow and I'll announce the winners.
Gotcha. So, 6 of us tried out. You, Max, Lizzie, RJ, Jeff, and me.
But only 3 of us are gonna make the team. How's Brawley gonna figure out the 3 best surfers?
I guess we need to compare how we all did. Let's ask Ada at the Learning League lab for some help. Hi, Ada. We're here at our friend Brawley's surfing tryouts.
How's it going?
Well, that's why I called you. We want to figure out how Brawley will pick the 3 winners. We're not sure how he'll compare how we all did this week.
Ah, I see. Well, did you have any ideas about how he might do that?
Well, out of all the waves I surfed, maybe he'd look up how many times I stayed up.
Sounds like you're on the right track. The way we represent that idea is through percents. We use them here at the lab almost every day.
Really?
Sure. Like when I got up this morning and listened to the weather report. The forecaster said there's an 80% chance of rain today. Definitely a day for staying indoors. And how about when you check out the top hitters in baseball? Did you know that a player's batting average is a percentage? It's the player's number of hits out of his or her total times at bat.
Surprised they didn't show Casey in that example.
Cool. That's kind of like us comparing who's good at surfing. The number of good rides out of total rides at the surfing tryout, right?
You got it.
But how come one number looks different than the other?
Aha! Let's take a closer look. Here's a little brain game to expand your sense of percents. Remember, percent means part out of 100. So, let's say you spent a whole day surfing and tried to ride 100 waves on your surfboard, but stayed up only 25 times. The percent of times you stayed up would be 25 out of 100, or 25%. We can show this by coloring 25 boxes in this grid.
25%! I did that on the first day of surfing.
Okay, so with practice you'd get better, right? Imagine that on another day, you stayed up on 70 out of 100 wave rides.
70 out of 100? That would be 70%, right? That's much better.
Exactly. And we're just denting the surface of percents. Percents can also be written in different ways.
Oh man, the background is a little glitchy.
One way is as a fraction. For example, you might also say that you stayed up on 2/5 of your rides. You can use a grid diagram to show this too, by first dividing the grid into fifths and then coloring 2 sections.
2/5 is the same as 40%. Awesome!
Percents can be written as decimals too. So if your surfing success rate was 0.6, you'd change 0.6 to the fraction 6/10, and then fill in the grid. 0.6 is the same as 6/10, or 60 hundredths, or
60%! I'm getting it! The grids make it so much easier to see.
Works every time! And here's a tip. You can use grid diagrams to help you compare percents, fractions, and decimals. Check out those surfing results again. According to the grids, which was your best day?
That's easy. The one where I stayed up on 70% of my rides.
And which was your next best day?
The 0.6 day?
Excellent! The grids show that 70% is greater than 0.6 or 61 hundredths. Now, let's fill in the rest of the numbers.
All right. Sorry about being quiet, but I'm just letting the lesson play out.
Let's do it! I've got the scores for all of the surfers right here. Look, here's Jeff's score. He stayed on his board for 55% of his rides. Here's May's score. She stayed up on 4/5 of her rides. Here's Lizzie's score, 0.3. Looks like Max stayed up on 3/4 of his rides. Wow! 85% of RJ's rides were good ones. And last of all, my score, 0.7. Hope it's good enough.
Find the grid diagram that matches this score. Click the arrows to scroll the grids. When the matching grid is next to the score, click Check.
That's it! That's it! A perfect pair!
Yep.
That's it! Good matching! That's it! Excellent! We matched all the scores. Come on, click continue so we can compare the scores to find the top 3 contestants. And check it out! 6 contestants, 6 scores, and 6 grids. Help me put them in size order.
Check out the grids. Then drag the highest surfing score to the first space on the bottom of the screen. Now drag the other surfers' scores to the spaces at the bottom of the screen. Put them in size order, from highest to lowest. When you're finished, click Check.
Try again.
Try again.
Check it out! RJ had the highest score. Now we know the top 3.
Oh, that's one by.
Let's do it! I've got the scores for all of the surfers right here. Look, here's Jeff's score. He stayed on his board for 55% of his rides. Here's May's score. She stayed up on 4/5 of her rides. Here's Lizzie's score. 0.3. Looks like Max stayed up on 3/4 of his rides. Wow! 85% of RJ's rides were good ones. And last of all, my score. 0.7. Hope it's good enough.
Find the grid diagram that matches this score. Click.
We need to add this to our records. Yup. Good matching. A perfect pair. That's it. That's it. Excellent. We matched all the scores. Come on. Click continue so we can compare the scores to find the top 3 contestants. And check it out. 6 contestants, 6 scores, and 6 grids. Help me put them in size order.
Check out the grids. Then drag the highest surfing score to the first space on the bottom of the screen. Now drag the other surfers' scores to the spaces at the bottom of the screen. Put them in size order, from highest to lowest. When you're finished, click Check.
You got it! RJ's 85% is the highest score.
There we go.
Good going! Now we know the top 3 surfers. RJ, May, and Max. Hey, that means I didn't make the team.
Well, you can't win every time, Ash.
That's
true.
But I was so
Does all that mean?
close. Just 5% less than Max.
You did your best. That's what's most important. Always.
Well, I guess I am happy for Max, May, and RJ. They're going to be so excited.
Now that's the spirit. Talk to you later, Ash.
Hey, I know. Even though I'm not on the team, I heard Brawley was also looking for someone to take photos of the show. Let's do it.
let's get to the and let's get to that.
That was awesome! I took lots of photos and I used them to keep track of each surfer's score. Come on, let's check to see who was the best surfer in the show. Look, here's May's score. She stayed on her board for 9/10 of her rides. Here's Max's score. He stayed up on 60% of his rides. Here's RJ's score, 0.8. Last of all, here's Brawley's score, 95%.
Move your cursor over the grid to fill in the squares that you need to build your chart. Start at the bottom. Click on any squares you want to remove. When you're finished, click Check.
Yep. Let's keep going.
Gotcha.
Yep. Let's keep going. A perfect pair. Let's keep going.
Somehow this is a lot easier than the previous section.
A perfect pair.
Now, click Continue to compare the scores to find the top surfer.
All right. Here are all the scores for the Board Blaster team. Help me put them in size order, from highest to lowest.
When you're finished, click Check.
Great job! 95% is greater than 9/10. 9/10 is greater than 0.8. And 0.8 is greater than 60%. Amazing! Brawley stayed up 95% of the time.
Are you
He's
really surprised
definitely
there?
The best surfer. Go Brawley! You guys were great!
Totally awesome, dude! And did you see May? She stayed up on 90% of her rides.
It was so amazing!
Thanks
Yeah,
for
I
taking
just saw
pictures,
that.
Ash.
And for figuring out our scores.
Hey, it's not a problem now that I know that grid trick.
Yeah, and it's too bad we didn't get to see either of you waving.
Thanks for your help,
That
too.
would have made it a lot
It's
more
all
visually
about
interesting.
teamwork.
You said it.
I'll slip up with some. This was another fun one. And now to move on to our last lesson of the num, in which we'll be tackling mean, median, mode, and rem. And wouldn't you know but this happens to be a Tracy plot. Where we find them collecting the data of the Pokemon that have been living around Professor Oak's ranch. He calls up Ada to show him the data he's collecting, which is the weight of the Pokemon he's observed. And thus Ada shows him the range, mean, median, and mode of the data set.
Hey, look! Professor Oak wants me to help him figure out some things about the Pokemon running around here today.
Snorlax.
Or not running. This data is important, so maybe I need some help making sense of it.
Sure.
Let's use the Pokepile to ask Ada at the Learning League lab.
Oh, that was
Hi,
quick.
Ada. I'm trying to organize some data for Professor Oak.
Sure. So what do you need to know?
Well, I have the weights for Pokemon in one area here, but Professor Oak wants to know some general things about the data.
Got it. Can you tell me what data you have?
Yeah, here are the weights of the 6 Pokemon in this area.
Snorlax.
Yep, Snorlax weighs 1,014 pounds. That's big. But then again, Oddish weighs only 12 pounds. That's a big difference.
And there's an idea that we'll use. You're talking about the difference between the smallest and largest number within a group of numbers, or data set. That's the range.
Oh, so Professor Oak might want to know how much of a difference there is among the biggest and smallest, right?
Sounds like it. The range can tell you if there's a big difference in weights, or if they all are pretty close in size.
So, Oddish's weight is the smallest, and Snorlax's weight is the largest in the set.
Yep. Now to find the difference, subtract the smallest number from the largest. What is 1014 minus 12?
1002.
Great. So as you said, the range between the weights of Pokemon in that area is 1002.
I got it. Now, what about this? Professor Oak wants to know the mean, so we can figure out how much food we'll need on average. Mean? All the Pokemon seem pretty nice.
Actually, you've already said it. In this case, I think he's talking about what a lot of people refer to as the average. The mean of a set of numbers is the typical value of that set. First, you add the different numbers together.
Let's see, that's 1,280.
Now to find the average, divide the answer by the number of Pokemon you started with, 5. What do you get?
1,280 divided by 5 is... $256. Wow! Snorlax's big weight really makes an impact.
So the mean, or average weight, is 256. Now, if we want to know what falls in the middle of the data set, that's the median. It's the middle number in a set of data, when the numbers are written in order. So first, put the numbers in smallest to largest, or numerical order. For our set, it would be 12, 33, 33, 188, 1014. What number is in the middle of the list?
33. It's right in the middle of 5 numbers.
Yup.
So the median is the number that comes right in the middle. But what if there are 2 numbers in the middle? I mean, if we had 6 instead of 5 numbers, there would have been 2 numbers in the middle. Which is the median?
Great question. An even amount of numbers in the set. Let's just say that there are 6 numbers in a data set, like this. Now there are 2 numbers in the middle of the set. The median, in this case, is the average of those 2 numbers. So, what's the average of the 2 middle numbers?
To find the average, I'd add 6 plus 8 and get 14. Then, I divide 14 by 2 to get 7. So, would the median be 7?
Right. Okay, on to mode. The mode is the most frequently occurring number in a set of data. In other words, the number that appears most often. Remember, our data set is 188, 33, 12, 33, 1014. Which number occurs the most often in this set?
Well, the only number in this set that appears more than once is 33. So 33 must be the mode.
Right again. You might want to find out what the mode is because the mean can be a lot higher or lower than the number that appears the most often, like in your case.
I see. There are a lot of ways to look at the same information.
Right. Each gives a different view on the numbers.
Whoops. Let's step out of the square there.
Okay. Hey, let's take a look at some more data for practice. Here's some information about weather at the lab. Review it and the range, mean, median, and mode. Then maybe you can help me. I'm compiling this data for our lab almanac. When you're finished here, click the Next button. Let's work through these questions about the dataset. Pick the correct answers for each question. What 2 numbers would you use to find the range? Right. The range is the greatest number in the dataset, less the least number. In this case, it's August's average temperature, 26.4 degrees Celsius, minus December's average temperature, 8.2 degrees Celsius.
What is another word for mean? Right. Mean is another word for average. Does this data set have a mode? None of the numbers in the data set are the same, so there is no mode. What is the first step in finding the median? Right. You need to put the numbers in order.
Now,
Alright.
now I need some help. I've got some food for some Pokemon on the grounds. Help them get to their food bins by using what we've learned about mean, median, mode, and range. What is the mode of this data set? Great! What is the median of this data set? Great! What is the median of this data set? Great! What is the range of this data set? Great! What is the mode of this data set? Great! What is the mean of this data set? Try again. Good work. What is the range of this data set? That's right. What is the mean of this data set? Good work. Thank you. Professor Oak is going to be really pleased with this information so we can keep the laboratory running smoothly. Now, I have to get back to work. It's feeding time.
Snorlax, snore.
Yeah, I know. I'll feed you first.
Okay. That was a lot simpler than I thought it would be. But anyway, Wayne, that'll about do it for this week's episode of MediaNutso Plays. And next Saturday, we're returning to the world of Freddy Phillips, and where we'll be cracking 2 more cases. In this case, the case of the stolen conch shell, and the case of the hogfish rustlers of Briny Gulch. Let me correct the first point. 2 weeks from now, for our next episode, so we'll be diving back into the world of Freddy Fish. Okay, that'll do. And so until then, this is MediaNutso saying thank you all for tuning in, and I'll see you on the next one.